All right. Very well. Good evening here. Should I start now?
Oh, yes, sir, we can start the session. No problem.
All right. Good evening, everybody, and welcome to this introductory lecture on well engineering. And a number of you guys know that well engineering is an important aspect of petroleum engineering. But what is well engineering? How is a petroleum engineer useful to the oil field? And there are many thoughts about it. People say, okay, they drill wells, they bring the oil out, they search for oil. All these things come in your mind, but what does well engineer do? So one part of well engineering is planning and design, and the other part is execution. We're going to touch both planning, design, and execution in this lecture, and I'll try to make it interesting for you guys, give you perspective of the way things are in the industry. Okay, next slide, please. So here is something about myself. Uh, I run a well engineering company, so I think I'm well qualified to give this lecture, given that I have 20 years of industrial experience behind me, 18 years in the industry, working as an engineer at different levels and capacities, and the last 3 years roughly um, as an owner of a well engineering company. So that said, I have worked for various deep water projects. The last one, of course, was giving consultancy to ONGC through a consultant company in Mumbai, my company, MD&K Oil and Gas Consultants. And then I have worked for major oils like Petronas, Statoil, Shell, BP, and I have an earned PhD in petroleum engineering and an MS degree as well. And in India, I did my MTech from the University of Roorkee. Now we call it IIT Roorkee, right? Next page, please. All right. So let's start with some very basic definitions, guys. What do petroleum engineers do? We develop and apply technology to recover oil and gas from shale, tar sands, offshore oil and gas fields, way in the most profitable and safe way. And we must devise new techniques to recover oil left in the ground. So that is where you come with enhanced oil recovery techniques. So that said, uh, that's petroleum engineering. Next page, please. So within petroleum engineering, you have the geologists, the geophysicists, yeah, the petrophysicists, the logging. So all this is from GNG side, geology and geophysics side. Then you have reservoir engineers, you have well engineer, the completion engineer, and production engineer. Many often they will say drilling and completion engineer, meaning the same thing, almost. Drilling engineer completes the well as well. All right. So what do each of them do? What are their roles? Next slide, please. So a geologist per se, he will find oil and gas, right? He does his seismic studies and does look at the outcrop and all that, right? But what does a well engineer do? He plans the well. The well which has to be put in the ground must be planned. And that's where a drilling and well engineer come into picture. So what is drilling and well engineer? Almost the same thing. Drilling engineer, some companies call drilling engineer, some companies call well engineer, like Shell we call well engineers, right? So we execute. Execute means you go and drill the well. To produce oil or gas reservoirs in minimally disruptive ways to ensure minimal damage to environment, public health, and property. All right. So that's in brief what a well engineer do. Now, if you're interested to be a reservoir engineer, you can look at reservoir engineering as well, completion engineering. So they're all interconnected, guys. It's not that if you are a well engineer, you will not need to know anything about reservoir engineering. You must, because reservoir characterization, yeah, methods, you must understand or at least have a basic understanding of the methods that will get the most of the oil and gas out from your reservoir. Likewise, completion engineer, what they do, they oversee well completion work. Production engineer, so once the well has been completed, start producing from the reservoir, the production engineers are in charge, basically. Right? Next slide, please. Next slide, please. All right. So today we are going to talk about well engineering in specific, and the buck won't stop there. We will go
Amir,
deep
hang
into
tin now. My cheese done.
well,
Chop the cheese. I finished cheese now.
offshore well engineering. Okay, guys. So
That's not sure.
where are the slides?
1 minute, sir. I just
Oh my God. Guys, advantage, where are the slides?
so minutes, sir. Give me a minute, sir, please. 1 second.
Last my life.
So while they put the slides on, you know, you plan well. It takes time. Sometimes in deep water, it will be 2 years of planning before you go and drill a well. At least the major oil companies, they will do that. So you must understand that a well engineer, of course, he has a design job in the office and then execution in the field. But for offshore deep water wells, there is much more design work to be done, yeah, compared to just onshore wells.
So,
Onshore wells may be comparatively simple, right? All right,
so you can share the screen now.
all right. So I can share the screen from my end.
Yes, sir, you can share now. The thing has been rectified now.
Okay. Let me see. Yes, I can. Very good.
That's okay. Yes.
Excellent. So we were talking about the steps to well planning and execution. The whole picture, yeah, you must go and obtain your seismic studies, look at the logs. You must scout for the information for the wells and all the offset information. Once you have done that study, you get the lease of the land or obtain concession. So in India, You have Directorate General of Hydrocarbons, which gives you the concession. Mind you guys, you just get the lease. You are a contractor. An operator is a contractor to the government to drill oil and gas wells. End of the day, the operator pays some money, some royalty to the government. Yeah. And once you have your lease, you get all the information, geological, and then you come up with a reserves estimate, best available data from, and then you say, okay, now I want to find out how much money is down there. And that's where the reservoir engineer comes in. He will run his simulation, all the work, and then meanwhile, you're also trying to get permits from the government. Once the permit is there, once your all the work is done, you start preparing the drilling and completion program. So guys, drilling and completion program is a very important thing when it comes to oh my gosh. So this thing, this drilling and completion program, basically I will be going through with the interns how to prepare a deep water drilling and completion program when we look into the internship opportunities at my company. Okay. But this is what you put together as a well engineer. And then you go for bids on footage, day work, combination, whatever it is. And then you select a drilling contractor, maybe the one who's drilling the well, the rig which is going to drill, and then you go and execute. Those were the different steps on well planning. And so that was overall picture. Now here comes what do you do as an engineer? The first, and mind you, when you do an internship at MDNK, all these 10 steps, you'll have to do it yourself. And in the end, you will be required to put together a drilling and completion program, which will include all these steps. So the first step is offset data analysis. You find out, about the well and offset wells and what can work in your well. And then the geology and geophysics will provide you pore pressure frag gradient plot. Yeah, we will discuss what it is shortly. Offshore considerations. So these are special considerations when you drill offshore or in a deeper water situation or any offshore well. Casing design. So there's a lot of confusion in young engineers' mind what it could be in casing design. And trust me, I will take you with very basic steps in a course which I'm trying to deliver next week. I think we will start delivering from 1st of March. And all these 10 steps, offset data analysis, pore pressure, frag gradient, offshore consideration, casing design, drilling fluids and hydraulic design, cementing design, logging, surveying, wellhead systems, well cost, everything would be discussed in that course. So if you are interested to, to get a feel of what a well engineer does and what his roles are and how to work out a well engineering program, you're welcome to look at that course. Yeah. Now, that said, just a minute. Dave, हमें जरा देखना वो बैटरी एकदम लो हो रहा है. All right. That said, we will. Yeah, Yeah, same low battery. Yeah, guys, sorry, my battery now was running out. Yeah, it's better now. Yeah. It's going in and out. All right. So what I was saying was all these 10 topics is what goes into a drilling program. And we will make sure that we discuss all these topics in detail in a course which commences a week from now. Okay. And if you're interested to know more about the course, you can get in touch with EDvantage. Next, let's talk about offset data analysis, the first one. Offset data analysis means if there has been a well which has been drilled next to your concession, yeah, in principle, you want to have access to that information and that data. Gentlemen, please ensure that your music systems are switched off. This is causing unnecessarily problem to everybody in the class. So what you want to make sure is you want to do a thorough analysis of this data, offset data, and try to plan a well which would be, if not exactly, but will be similar to the one which has already been drilled, and you learn from their problems. So if there was a drilling problem and you were not able to identify an overpressure zone, that would reflect in the mud logs or the well logs of that well. And when you identify those problems, those challenges, I'm sure that you will not repeat the same problem again. Likewise, a seismic cross-section, it can identify, like this particular figure here, you see, in seismic cross-section, yeah, between the wells, you can see curvy lines going on. So different stratigraphic correlations can be made, right? And drilling and completion reports. The reports will tell you where you have taken in kick, or if there was a mud weight increase at a particular depth, or what kind of hole sizes did you run. So things like that will get clearer when you review your offset data, and with that review, you can build a robust well design. All right, guys. Next is the Ppfg plot, and what it is a window, yeah, between the pore pressure and the fracture gradient. So what happens if you go below the pore pressure plot? You take a kick, right? And what if you go above the frac gradient plot? Well, if you go above the frac gradient plot, you will damage the formation. There would be a fracture. And then what? With that fracture in, you will start losing mud. So you want to avoid both the extreme cases. And it is the geologist who provides you this pore pressure frac gradient plot. And this is where your well engineering 101 starts, guys. So make sure you have good friends with the geologist. This plot will also give you a drilling window. So what is your window? It's a window between kick, your pore pressure graph and the frac gradient curve, right? Between the two curves. That's where your drilling window is. Casing seed selection and mud program. You develop the seed selection and mud program based on this plot. And then, of course, you look at the geomechanical study. And what is it? It's the study of the stability of the formation. So the formation doesn't cave in. Yeah, your previous well data, your offset well data will be able to say something on this, and your geomechanical expert will give you a possible mud weight usage chart based on his detailed study. So with all that information handy, you start your well planning, basically. Okay. So the first thing is seed selection. So what is seed selection? On my left hand, on the left hand of the figure, you see this Ppfg plot. And so on the blue line is your pore pressure plot, right? Then we add to it the dotted line, which is nothing but maybe 0.5 ppg of safety margin. Why we want to keep a safety margin? Who knows, there is an error in determination of the pore pressure graph, right? So we keep a 0.5 ppg safety margin. And likewise, there's a 0.5 ppg safety margin on the red curve, which is your frag gradient curve. So your window to drill is between the pore pressure and the frag gradient curve, right? So, okay. So between the two dashed lines, you see I have put some arrowed lines here. So this is the maximum mud weight you can have at the surface, and then you can go to a certain depth. And then you put your casing there, and then you increase the mud weight, and then again go about your work. So this is how, guys, you put together a seed selection. And once you have this seed selection program, you do your mud. Hello, hello, please switch off your radio. So once you have your seeds selected, you can design your mud weight graph. What would that be, guys? It would be, you don't really increase the mud weight, like here, what we have done from this point E to D, say for example, yeah, you see a jump, but that's not how you increase mud weight. You increase mud weight gradually. So what would your mud chart look like? Mud program look like? We will look at that when we do the detailed course. But for now, you should know that this is what you are expected to put together in a drilling program. You're increasing mud weights, you see, 8.6, 10.5, 11, 13. You gradually increase the mud weights with the depth, and it's not just the weight. You also look at the PV, YP, API, fluid loss, pH, chlorine, all this. So this is all part of fluid engineering, guys. And we shall discuss some of this information as well in the course, okay? Now, further to that, we will talk about casing design. And when we talk about design, you need to identify the basic casing which we run in a well. The conductor is the topmost part of the well, the conductor casing. Then you have a surface casing, which is put below the conductor. And then you have an intermediate section, a production section, and you may have a production liner or just a drilling liner. So we will discuss all that in the course, guys. Next, there is a geomechanical study I told you about, and here is a quick picture of same. And what this plot shows to you is the different mud weights you will be having while you drill the well, making sure that the well bore is stable. You make sure there's no caving, no fall of the mud in the no fall of the formation in the mud, and the stability is ensured. So this is a plot which you get for the wellbore by your vendor, and they are made with mud weight and stress considerations and all. So it's a good study to have part of your planning process. Having said that, the next we are talking is offshore considerations. So like I told you, well planning can be for an onshore well or for an offshore well, right? So when we say on offshore well, what are the special challenges? Wind, waves, environmental loading. What does that mean? These forces do make a difference to your offshore vessel and the loads which are eventually transmitted to your wellhead system and the BOP. So we'll discuss this in detail more, but you will have challenges like loop currents, hurricanes, yeah. Then you will be worried about low temperatures, high pressures, yeah, shallow hazards, subsea, cementing challenges, temperature effects, narrow pore pressure frac gradient challenges. This is a big challenge in offshore consideration. You may have salt drilling. So all these challenges would be discussed in this topic, which is days, basically an hour lecture on offshore considerations. Okay. Next, in the course, we will discuss casing design. And this part would be very interesting for young engineers because so far you have heard that yes, the stress check can do me the calculation, all that. It's like I put in something and I get a design out excellent. But guys, you need to know how these calculations are done. What is meant by a mass? Yeah. What is a surface pressure? What is casing test pressure? How do you come up with a burst and collapse design factors? What is a tension design factor? How are you going to determine which casing is the best casing for your well? What are effects of axial tension on collapse strength? So these are the things which you should understand and you should have concept on. If you have good concept on these topics, half of the work as a well engineer in the oil field would be done because half is well planning. And well planning is what? Well planning is to identify the well design, where you're going to put the casing at different depths. That's a very important part of casing design and well engineer's job. Okay, so I will teach you, and if you come to the course, you will know. You see, this is an Excel sheet, and in this Excel sheet, you see very simple calculations, and you will have the PC, say for example, and the safety factor. So what is the collapse pressure? What kind of safety factor or collapse design factor have been taken? And your software in stress check will also give you a safety factor. But here in this course, I will teach you how do you get a safety factor of 2.09. You have PB, the burst pressure of 1196 psi. How do you get that? And your stress check will give you a safety factor of 3.28. But how do you get there? So all these calculations, we will discuss in the course. Next, drilling fluids. Like I said, the drilling fluids is a whole system in itself, right? So we will spend one day studying the fluid system and the hydraulics. So the circulating system, what it consists of, all kinds of equipments on the surface, the pipes, including drill pipe, in annular areas around drill pipe, drill collars, drill bit. Very simple words. And we will do some numbers to identify what kind of circulating pressure losses we are talking about. Okay? That said, so this all what I am discussing, guys, is basically what a well engineer is supposed to know. So this 1 month course which we are going to offer would give you a good idea about all these aspects. We will consider a day for each of the topics. So this is nothing but, what kind of mud you're using, what kind of weight, theta 600, theta 300, and then you kind of come up with the right mud for your given whole section, stuff like that. So we will talk about that. Cementing design. If you're talking about cementing design, a deep water well would have design which would be different. Yeah, guys, the designs would be different for different hole sections. The cement design for top hole will be very different from the intermediate section and for the production section. Why? Because the conductor cement design should be such that it should help the well to hold the load of the BOP, the well itself, and should be strong enough to sustain for 30 years. It should not allow any kind of what you call seepages or unwanted leakages from the conductor to surface casing. Intermediate section is different design. Production casing, that's a different design. Why? Production means you have oil and gas there. You must have good cement there, a strong heavyweight cement there to prevent any kind of leakage to the well. Now that's not all. The cement on the production casing or production liner for that reason is there to ensure that the oil and gas can produce effectively. You will have upper and lower, cement zones. Yeah. So each one of them would have a different weight. And the lower one would really be trying to ensure that the cement integrity and on the wellbore is strong. The upper one would be a lower weight. And why lower weight? Because you want to make sure that when the cement is green, it does not go beyond the front gradient of the formation. So we'll talk about cement design, and here is a cement design example, guys. All this you will have to put together in a drilling report if you were going to do what you call an internship with MDNK. Likewise, we will spend a day on logging and surveying program. So here you will talk about AutoTrack and MWD and LWD and all kinds of digital instruments which we use in the oil field and their purpose and how they are effective in the oil field, both offshore and onshore. BOP systems. So what does a BOP consist of? In subsea systems, BOP would have upper and lower stacks. So the upper stack is called LMRP, the lower one is lower stack or BOP stack, what we call, and all the different elements which go with BOP systems. So, um, you can have the different ways to control the well using the ramps, and we will discuss the different ramps as well. So, likewise, the subsea wellhead system. Here you will see that we are going to discuss about deep water wellhead system. But yeah, these are a little different from your uh, wellhead systems on land, and primarily because you have a different locking mechanism in subsea systems versus what it is on land. So on land, you have one nipple over another, and you build upon from one casing wellhead to another. Here you go south, whereas in land you go north. We'll discuss this. We'll spend a day talking about wellhead systems and what a rigid lockdown means. Why is it so important to have a rigid lockdown system in a deep water system? And the different kinds of shoulders available in a wellhead system, for landing different, uh, yeah, the different kinds of wellheads. Maybe you have 13-inch, 20-inch, 16-inch, 18-inch. They should all have a profile where you can land. Then, guys, we will talk a day on well completion. So basically, we will be discussing the lower and upper completion, and what the lower completion and the sand packs and open hole, and uh, how and what they are basically, and some things on fracture design as well. Whereas upper completion will talk about all the the different kinds of PRSs revolve, AS revolve, and how you control the well as and when you like. And of course, the jewelry, the equipment which goes there would be discussed uh, in the planning and execution of parts of that course. Well, cost, here, how to put together an AFE. That's what we are going to discuss, guys. So the different components of the well, like the casing, the tangible and intangible, what we call. So tangible and intangibles, which you spend and you will never get the money back, right? And the tangibles are, tubing, casing, which may be recovered if you like. So, and how does the partners contribute? What is the kind of agreement they have? And how you come up with the day's depth curve? All this would be discussed, okay? So, management authorization is also important. And once the engineer puts together a cost estimate, like this particular well was drilled in Gulf of Mexico way back in 2003, I believe, $19 million. So we put together the AFE and the management approves it. And then there is this process to also get the supplementary cost estimate. And then we'll talk about post-well analysis for a day. Basically, what did you learn while you drilled the well? So that would be like what I would be, doing as a drilling engineer. But that is just the beginning of the story, guys. Why I say that? Because this course which we are offering to you would consider all these aspects, fine, but that's like today you learn, okay, these are the aspects, but what next? The next part of it is obviously to work on a drilling program. And if you can put together a good drilling program, and I will provide you all the basic information to put together the program, and every intern would be getting his own, uh, problem set, and then The fun is in trying to work it on Excel uh, on your own with my guidance on it. So that's the whole objective. So today is Prelude. Then in a week's time, we will start with a detailed 1 month course, which will consider each of the different topics we have discussed here um, in detail. And once the course is over, my expectation would be from the best and brightest amongst you, based on some assessment technique which our advantage guys will put together. And basically, we will, uh, based on that, we'll select a few guys, and you will get to do the work hands-on with me. So, yeah, I have many case studies like that. So we will discuss case studies. We will discuss the planning part first, and then we will do the execution part in terms of the drilling program. And once that is done, you can submit that to your university for internship learning. And I'm sure now coming to internship topic, guys. I understand that a, a well engineer, or for that reason, any petroleum engineer, must have hands-on experience. Unless you dirty your hands, your knowledge is incomplete. However, in the COVID scenario we are, and you must complete your degree on time. Um, I mean, there's a great opportunity to hone your engineering skills. Guys, you're not the driller, you are engineer. And an engineer must understand the basics of well engineering. And you must be able to design a well. That's most important. And this is what we will cover in the course. So thank you very much for your undivided attention. And if you have any questions, I'm open to them. Feel free to ask me questions. Advantage, back to you.
Yes, sir. Hello, so is it? Hello? So is that I'm audible?
Yeah, you are audible to
Okay. Students, if you have any questions, you can directly ask to sir, or you can just type your questions in the chat box so that we can convey.
Yeah. So I see a question coming from Aju Ansar, and he's saying, please arrange a training in your company. Well, Aju, you will have to take the assessment from Advantage, um, be part of the course, and definitely I wish you good luck. And then MDNK will arrange your training um, for your internship. Likewise, I welcome all of you, all of the participants to join this 1 month course, and let's do a good job. So Anup Antony to everyone. Anup is saying MDNK arranged pressures. I didn't understand arranged pressures. I mean, yeah, it would be training for freshers. Yeah. fourth year engineers, I believe. No, this is not a job. This is learning. Good engineering so you can apply it in your job. Now, if things go better in months and years to come, and the business takes an upturn, and you have done a good job in your internship, I can as well hire some of you, but that's not part of the agreement here. It's more about your performance and your learning as an intern, where an MD&K is going to support you in that. Mohammad Ismi Afif, how to take part on that internship? Oh, it's very simple, Afif. There is a course like I discussed a week from now, and I think EDvantage will provide you that basic information. We will discuss detailed well planning and engineering there. Based on that, you will be given a test, and depending on your performance and your assessment, uh, we will decide to choose. I can't really take a whole lot of people on internship, guys. Trust me, for putting a drilling report, I used to work as much as 2-3 months in advance before the report comes through. So you will be working with me on a detailed well report, and that is going to take significant amount of time. And once that is done, you can submit that report to your university, and I hopefully you will be proud of what you did. You learned something instead of just you know carrying a handle in your hand, going to some field and not do much. Of course, you learn something in the field as well. But here, what you learn is what an engineer should know as a well engineer. Should us finish some cases from you, sir? Yeah, you can have some cases planning job. Yeah, you can, Franklin. Um, we'll talk about the cases in the course, definitely, next week. Rehan has give me an introduction about MPD. Well, we will discuss MPD. It's a modern technology. It's a technology to drill wells, particularly with low pore pressure frac gradient um, windows. And like I said, in the offshore environment, given this is an offshore-oriented course, MPD has a very strong emphasis, Rehan. I drilled several wells in Malaysia for Petronas, and most of the wells, I would say, had NPD on them. So we will definitely discuss NPD in the course uh, we're going to start next week. Oil industry are upgrade to digitalize. Yes, that's right. Digitization is the next big thing in our industry, which is happening already. And MPD is a direct application of digitization. We have to learn to improve our skills. So nowadays, how MPD plays in the oil and gas. Yes, we will discuss that, Rian. Definitely. Thanks to the organization. You're welcome, Anup. Thanks to EDvantage too. Any more questions, guys? Welcome, Rehan. And I mean, you guys are welcome to connect with Advantage. You have any questions, you can directly throw at me as well. Um, I would be very happy if you can learn something from this presentation, this webinar. Uh, but more so, the detailed thing, the meat would really come in the detailed course, the month course we are offering. Great. Back to Advantage now, unless there are any other questions. Ali Shandy says, thanks for introduction, Dr. Nitesh. Well done. Okay. Thank you, Ali. Nitesh, you there?
I'm here, sir, from Advantage.
Very good. So if there are no questions, we can wrap it up, or you would like to say something?
Students, if the course is more interesting, we would like to ask you to contact Advantage for more details, and we are here to help you out. Uh, Thank you for your time. Thank you, sir. Have a good day.
Thanks. Okay. Bye now.
Bye, sir.